Hey, in this tutorial we're looking at section 7.2 on antidifferentiation. So antidifferentiation is the opposite of differentiation. So we've got some notation here that we need to get used to. Okay, so we have our integration sign out the front, okay, of our function f of x dx. And always got to make sure we write our dx, okay, or whatever one we need to use, because the x tells us what variable we're integrating with respect to. Just like when we were doing differentiation, we'd say derivative of y with respect to x, or derivative of x with respect to t. Okay, same idea here. We need our dx at the end. Okay, and we read this as integrate f of x with respect to x. So we integrate f of x with respect to x. Okay, so we've got a few identities here that we can use. So if we integrate x to the power of n with respect to x, then it becomes x to the power of n plus 1 divided by n plus 1. So we're saying that basically you add 1 to the power and divide by the new power, and we have to put this plus c on the end. Okay, we've got to add this constant on. Okay, and we're saying n is not equal to negative 1. We get to how we integrate that later on. Okay, if we have the integral of ax to the n dx, well, we can simply take a constant out. So if we just got a constant that we're times a function by, we can bring it out the front. Okay, and so what that means is we're going to end up with ax to the power n plus 1 over n plus 1 plus our c. And again, our n can't equal negative 1. Okay, if we have two functions added together, okay, that we're integrating, we can integrate them separately and add our results. Similarly, if we're subtracting functions, we can integrate them separately and subtract our results. As I said a minute ago, if we've got some function that's multiplied by a constant, we can simply bring that constant out the front. Okay, if we're integrating ax plus b to the power of n dx, okay, then it's our ax plus b to the n plus 1 over a times n plus 1 plus c. So basically you're taking the coefficient, okay, of our x term, okay, and timesing that by our n plus 1. So we'll start looking at some of our worked examples. Okay, so we'll look at our first worked example here of integrating 3x to the 4 take x cubed plus 2 dx. Okay, so we can integrate that separately. So basically we're saying, well, we integrate the first part here. So we raise our power by 1 to make it 5 and divide by that new power, minus x to the power of 4 over 4, because we increased our power by 1, plus our 2, well, the power of x at the moment would be 0, so it just becomes 2x, and you can say over 1 if you like, okay, plus a constant. Okay, so we've got 3x to the 5 over 5 minus x to the 4 over 4 plus 2x plus c. Okay, now we could make these the same denominators, okay, to make them look a little bit nicer. Okay, we could absolutely do that. If we did, and I'll just show you really quickly what would happen. Okay, well, we need to multiply this one by 4, okay, and make it 12x to the 5 minus, well, I had to multiply this one by 5, 5x to the 4. Plus, I'd have to multiply this one by 20 and make it 40x, okay, all over 20. Now our c doesn't have to be plus 20c. Okay, it can just be plus c, because 20 lots of a constant is still a constant, so it actually doesn't matter at all. Okay, so you don't have to do multiples of your constant. Okay. Now we need to find an antiderivative of this. Okay, this term there. Okay, so what we need to do in order to do that, the easiest way is to expand our brackets first. Okay, so we're going to integrate 2x minus 3 times 4 minus x. We're going to expand our brackets first, so we get 8x, 8 minus 2x squared, 8 minus 12 plus 3x. So that would be integrating negative 2x squared, 8x plus 3x is 11x, 8 minus 12. Okay, so we can just simply now integrate that. Okay, so increase our power by 1, to the 3 divided by our new power. Plus 11x squared over 2 minus 12x plus c. Don't forget the c. For our next one here, okay, we've got if the derivative equals this, find the original. Again, we're just going to anti-differentiate. Okay, so for this one, what we want to do is we want to integrate 2x to the half. Okay, so change your square root to the power of a half plus x to the power of negative 2. Okay, when we're 1 over something, you want to make it to a negative power. Minus 7. Well, I've got my dx up there. I just realised that because I need it down here. Okay, so we need some dx's here. Okay, so we need to increase our power by 1. Be 2x to the 3 on 2 divided by 3 on 2. Okay, plus will be x to the minus 1 over minus 1 minus 7x plus c. Okay, so we fix this up and make, if we flip and multiply, we'll get 4x to the 3 on 2 on 3 minus 1 on x minus 7x plus c. Okay. Now we've got this one here. Okay, so we want to integrate x to the 4, take 2x cubed plus 5 over x cubed dx. Split this into separate fractions is the easiest way. So we're going to go x to the 4 over x to the 3 leaves us with an x. Minus, well, 2x to the 3 over x to the 3 gives us minus 2. Okay, and then will be plus 5 over x to the 3, so I'll make that 5x to the negative 3 dx. Okay, now we can actually integrate that, so it becomes x squared on 2 minus 2x, okay, plus our 5x, got to add 1, makes it negative 2 over negative 2. Okay, so we could say that's x squared on 2, take 2x, okay, minus 5 over 2x squared to make it look a little nicer. Okay, so we've got a few more worked examples to go. Okay, so we want to find we want to anti-differentiate these. Okay, so we're trying to find 2x plus 3 to the power 5 dx. Okay, so this time, okay, what we do is we increase our power by 1 for up here. Make it 6. Okay, over, now it's the coefficient of x, which is 2, times our new power, which is 6. So we get 2x plus 3 to the 6 over 12. Okay, similarly on this one. Okay, we can actually ignore our 2 at the moment. We're actually allowed to write it like this. X minus 1 to the minus 2. Allowed to write it like that, dx. Oh, and I forgot my c on this. Okay, it can be a little bit easy to forget our c at times, but we need to make sure that we put it on. Okay, so we simply have 2 times, well, we've got to increase our power by 1. I get negative 1. Okay, over 3 times negative 1. Okay, so we can say, and that's plus c, and say, well, that's 2 times 3x, take 1 to the negative 1 over negative 3 plus c, or we can say it's negative 2 over 3 times 3x plus 1, minus 2 over 3 times 3x plus 1, okay, plus c. Sorry, that should be take 1. Take 1. Okay, we'll keep moving on. There's still a little bit more to do. Okay, integration by recognition. This can be something that's a little bit tricky to get your head around. Okay, because sometimes we'll need to anti-differentiate a complex function. Okay, in these cases, it can be best to differentiate a similar function and use the result to anti-differentiate the original function. Okay, this is best explained through a couple of worked examples. Okay, so worked example 4, okay, we want to find the derivative of this, okay, and hence anti-differentiate this. So we'll start by finding our derivative of this. Okay, well, our dy dx. It's going to be, we've got to bring our 5 down. Okay, multiply it by the derivative of what's in here, which will be 6x plus 4. Okay, times by 3x squared plus 4x minus 7 to the 4. Okay, now remember this is by using the chain rule to differentiate that. Okay, so what we want to do, okay, is we want to make it similar. Like we want to have a look at this, and it needs to be similar to this. Okay, and you can see we're very similar here. Okay, that's what we want. But this is 3x plus 2. We've got 6x plus 4. So what we want to do is take 2 out as a common factor. Take 10 outside of 3x plus 2. 3x squared plus 4x minus 7 to the 4. So now we're very similar. You can see here 10, 20. So we're very similar. So what that means, okay, is we can say, well, if we were to integrate this or anti-differentiate this, okay, with respect to x, well, we know that we're going to get back to what we had here. Okay, we know that's going to happen. Okay, so we can say, well, that's going to equal 3x squared plus 4x minus 7 to the 5. Okay, you go, well, if we're trying to integrate this, okay, we're going to try to integrate this, well, really, we need to go, well, this is twice as big as this, so we need to go 2 times our integral of 10 times our 3x plus 2, 3x squared plus 4x minus 7 to the to the 4 dx. Right, and we know then, well, that's got to equal 2 times what we had over here. Okay, so if we know that we're looking for something that's twice the size of this, okay, well, when we anti-differentiate that, it's going to be twice the size. Okay, so we can say then that we're going to integrate 20 times our 3x plus 2, 3x squared plus 4x minus 7 to the 4 with respect to x. Well, that's going to equal our 2 times our 3x squared plus 4x minus 7 to the 5. Okay. So we've got another worked example here, which is anti-differentiate this function by first differentiating a suitable function. Okay, so if we're going to differentiate a suitable function, it's going to need to be a higher power up here. So what we're going to say is, well, let's say y is equal to x cubed plus 1 to the power 6. Okay, so when we differentiate it, we're going to get a lower power. Okay, so if we do that, say, well, dy dx, okay, it's going to be, we're going to bring our power down, 6 times our derivative in here, 3x squared times x cubed plus 1 to the power of 5. Okay, so you can see now we've got something here, this part looks very, very similar to what we had up here. Okay, so if we were to now anti-differentiate this, okay, let's say 6 times our 3x squared times x to the 3 plus 5 dx. Okay, well, that's going to give us our make a couple of mistakes here, x cubed plus 1 to the 6. Okay, so we're getting there and we say, so that would be 6 times it. Okay, so if we just want 1 times it, then it means that we can say the integral of 3x squared, x cubed plus 5 dx is going to equal x cubed plus 1 to the 6 over 6. We've got to divide it by our 6. Okay, because it was too big, our derivative that we had was too big. Okay, so we need 6 times what we had there to get back to what we wanted over here. Okay, so to find this bit, we had to divide it by 6. So that word example isn't actually in the textbook. It's just one that I want to chuck in because they have skimmed over the integration by recognition a little bit in the textbook. So just be mindful of that when you're doing the questions, and really make sure that you have a good crack at the integration by recognition in particular.